Hello viewers, welcome back to another section of my tutorial, and in this video I'm going to solve a differential equation problem. So this problem happens to be a linear as well as non-homogeneous and a second order differential equation, and I'm going to use the method of variation of parameters to solve this. Kindly watch this video to the end and also don't forget to subscribe. Okay, so to start with this, always whenever you are being given a second order differential equation which is non-homogeneous, first write the homogeneous equation or the homogeneous form. So in our equation, first of all, it's advisable to divide through by the common factor 4 that we have here. So we get y prime prime minus y prime minus 2y is equal to 2 multiplying e to the power negative t. So once I have this, I'll come down to write my homogeneous form, which is y prime prime minus y prime minus 2y equals 0. Once I get the homogeneous form, I have to apply my characteristic equation and find my complementary solution. So my characteristic equation is going to be r squared minus r minus 2 is equal to 0. And what am I going to get for r? So I have the factors of, I'm going to have factors of negative 2 that when you add, you get minus 1. So that is going to be r squared minus 2r plus r minus 2 is equal to 0. And this is also the same as r squared plus r minus 2r minus 2 is equal to 0. So when I further simplify this, I'm going to get r open bracket r plus 1 minus 2r plus 1, which is saying that I'm going to have r plus 1 r minus 2 equals 0. Therefore my r is equal to negative 1 and 2. Now I've got my r, I can move ahead to find my complementary solution. Therefore my yc is simply equal to c1 e to the power, then the first one, negative t, plus c2 e to the power 2t. So this is my complementary solution. The method of variation of parameters would say that to find a particular solution yp is simply equal to changing c1 to rather u1 e to the power negative t, then plus u2 e to the power 2t. So once I have this, the next is to find u1 and u2. But whenever you have a solution, you have to differentiate it so that it satisfies this equation. And when you do that, you are going to be left with a system of equations which you use a Cramer's rule to solve. So let's see, from here we move away to find our Wronskian of this coefficient of the u1 and the u2 respectively. So you just take the determinant of here, e to the power negative 2, then e to the power 2t. I'm going to differentiate here. I'm going to get negative 1 e to the power negative t. This is going to give me 2 e to the power 2t, like this. So what do I get? I'll multiply this and this, and I'm going to get e to the power negative t, multiplying the expression 2 e to the power 2t, then minus the expression of this negative e to the power negative t, multiplying e to the power 2t. So what do I get for here? This is going to give me 2 e to the power t, then plus 2 e to the e to the power t. So this is going to give me 3 e to the power t. So once I have the 3 e to the power t, this is my Wronskian. And from the system of equation, we are going to write that equation to be equal to this in angle brackets, e to the power negative t, negative e to the power negative t, e to the power 2t, then 2 e to the power 2t, all multiplying u1 prime, u2 prime, then is equal to, here you write 0, and here you write our g of t here, which is 2 e to the power negative t. From the question, g of t, 2 e to the power negative t. So once I have this here, what am I going to do? I'm going to apply the Cramer's rule to find my u prime of 1. So my u prime 1 is simply going to be this, the determinant of replacing this place with this 0, 2 e to the power negative t. Then I'll come here to be e to the power 2t, 2 e to the power 2t, like this. Sorry, is the determinant all over our Wronskian. which is 3 e to the power t. So what do I get for this? I'm going to get this times this, which is 0. So 0 minus the expression this times this. When you multiply this, you know that you get 2 open brackets, the powers to add, you get positive t, which is the same as negative 2 e t. Therefore, my u prime 1 will be equal to negative 2 e to the power t over 3 e to the power t, which is the same as negative 2 on 3. Therefore, my u1 will simply be equal to integral of negative 2 over 3 dt, and it's the same as negative 2x over 3, and that is my u1. Now, coming back to u2, applying the Cramer's rule, u prime 2 will be equal to the determinant of, now I'm going to maintain this, e to the power negative t, then the down is going to be negative e to the power negative t, but here will rather be 0, 2 e to the power negative t, like this, all over my Ruskin 3 e to the power t. So once I have this, I know that this times this minus this. So this times this, I'm going to get 2 multiplying e to the power negative 2t minus 0. So 2 to the power e to the power negative 2t all over 3 e to the power t. And that's going to give me 2 over 3 e to the power negative 3t, like that. And that is u prime over 2. So to find u2, integral of this expression, 2 over 3 e to the power negative 3t dt. And how do I get this? I'll bring my constant out, 2 over 3, and it will be multiplying. So here you get negative 1 over 3, then e to the power negative 3t. This is from calculus 1, so we get negative 2 on 9 e to the power negative 3t as our u2. So now let's come and write our yp once again. So our yp will simply be equal to our, initially it was u1, so wherever you see u1, our yp, wherever you see u1, you come and put the value for u1, which is negative 2x over 3. So negative 2x over 3 multiplying the expression e to the power negative t, then plus my u2, where my u2 is equal to this place, negative 2 over 9 e to the power negative 3 on t. So negative 2 over 9 e to the power negative 3t, as you have here. So that gives me my particular solution. So this is my u2. It's also multiplying the expression e to the power 2t, e power 2t. So let me further simplify, and I'm getting negative 2x on 3 e to the power negative t minus 2 on 9. This will multiply, and it will be left with e to the power negative t. So this becomes my particular solution from what I'm having here. So at this point, what do? I find my general solution y to be equal to yc plus yp. Therefore, my y will be equal to c1 e to the power negative t plus c2 e to the power 2t, then plus minus 2x e to the power negative t minus 2 on 9 e to the power negative t. Thanks for watching. Don't forget to subscribe.